that is question number one more part of this, that is D part of question number 6, that is we can easily move our hand in air. I can easily move my hand in air, but to do the same through a solid block. If I have a solid block and if I want to move my hand in that solid block, can I move? No, but I will need a karate expert. Why? Suppose children, this is a solid block, and if I want to move my hand inside it, in air I can easily move, but if I want to, suppose this is a solid block, and if I want to move my hand inside this, then I will need a karate expert. Why? The reason being the same, that in case of solids, the particles are very close to each other, force of attraction is very high, and if this is of course a small piece, but if you have a bigger one, solid block, then you will need this karate expert. They are having their energy is higher, and with pressure they will strike that solid, and then they can easily, they can not very easily, but they can break that and they can move their hand inside it. But in case of air, because in air is what? Gas, and in gas the particles, they are very far away, and therefore force of attraction is least, you can say, and therefore I can easily move my hand. Then next question children, that is 7th question of your study material. Liquids generally have lower density as compared to solids, but still ice floats on water. Why? Usually we say that the liquids, their density is less, and solids, their density is more. They are heavy. Liquids are lighter, solids are heavier. But ice is what? Solid form of water. That ice, you might have take out one ice cube from your fridge and put it in water. You will see that it is floating. Ice is solid, but why it is floating on water? Water is liquid. So what is the reason for this? The reason being that in case of ice, ice is what? Frozen form of water. This is liquid and this is solid. But if you have a glass and in that glass you have water and of course you have ice also, a piece of ice, then you will see that this piece of ice, it will float, and this is water. This is solid and this is liquid. Liquid is lighter, solid is heavier, but this still ice, it is floating. Actually it should go down, but what is the reason for floating of this ice? Because in case of ice, what is ice? Frozen form of, solid form of water. And what is the chemical formula for water? H2O, right? So this is H2O, this is one more H2O, this is one more molecule of H2O, and one more, like this you can have so many. Now in case of water, these molecules, they are closer, but if it freezes, it becomes ice, then you will see that in between the hydrogen there is bonding. This is called as hydrogen bonding. And this hydrogen bonding, it gives a cage-like structure. Cage-like structure it gives in the ice. And because of this cage-like structure, there are large spaces in between this hydrogen and oxygen, or you can say the molecules of water. There is large space, and because of this large space, the volume increases. Volume increases. Volume increases. And because of this increase in volume, what happens? D is equal to what? M upon V. If this is more, then what will happen? This will be less. Density will be less, right? And that is the reason density of ice is less, and this ice, it floats on water, right? So, what is your question? That ice is a solid, water is a liquid. We know that liquids, they are lighter than solid. But in case of this, though ice is a solid, but it floats on water. What is the reason? That in case of ice, the molecules of water, here in between hydrogen atom, there is a bonding, and this is called as hydrogen bonding. We call it as hydrogen bonding. And because of this hydrogen bonding, there is formed a cage-like structure of particles of ice. And in between this cage-like structure, there are present large spaces. Large spaces are there in between the particles of water, this ice. And because of this large spaces or cage-like structure, volume increases. As volume increases, what happens? Density decreases. And because the density decreases, therefore, the ice floats above water. Though ice is made up of water only, but it floats. And though it is solid, but still it floats. So, this is about the explanation of the 6th problem of your study material, and all these problems, they are given in your NCERT book. Then next is convert the following temperature to Celsius degree. 8th problem. Convert the following temperature to Celsius degree. First given is 300 Kelvin. To change this Kelvin into centigrade, you have to subtract 273 from this, and you will get 27 degrees Celsius. But why you are subtracting 273 from here? Because we know that if we have a thermometer, and this is a thermometer which is graduated, of course. If this is 0 degree and this is 0 degree means freezing point of water, and this is 100 degree boiling point of water. Here we are taking in centigrade. Then this 0 degree centigrade, it coincides with 273 Kelvin. On Kelvin scale, here it is coinciding with 273. So, whatever temperature it is given here, you have to subtract 273 from that, and you will get this temperature in degree Celsius. Then next given is 573 Kelvin. Again subtract 273, you will get what? 300, right. In this way you can convert Kelvin into Celsius. Now, if I ask you to convert Celsius into, suppose I ask you 25 degrees Celsius, convert it into Kelvin. What you will do? You will add 273 to it. That will be 298 Kelvin. If you are asked to convert centigrade into Kelvin, then you have to add 273, and if you are asked to convert Kelvin into centigrade, then you have to subtract 273. What is the reason? I told you that 0 degree Celsius, it coincides with the 273 Kelvin. That is the reason, right. Then next problem of your study material, that is 9th problem, children. Then 9th problem of your study material, children. What is the physical state of water at 250 degree Celsius, 100 degree Celsius, 0 degree Celsius and 25 degree Celsius. What is asked? What is the physical state, whether it is solid, liquid or gas, at what temperature? 250 degree, 100 degree, 0 degree and 25 degree. Now, we know that 0 degree, at 0 degree what happens? Water, it means completely it does not changes to the you can say solid state, but it is coolest, the temperature is coolest, and at 100 degree what happens? It starts boiling, but still it has not completely changed into, it starts vaporizing, it starts changing from liquid to the gaseous state. So, 250 degree, it is above 100 degree, it means what happens? Most of the water it has changed into vapors, and here the state will be gaseous state. At 100 degree it will be liquid, but it will be changing into vapors or gaseous state. At 0 degree it will be liquid, but it will start solidifying, it will start, a little bit of it will start solidifying, and at 25 degree again it will be liquid only, there is no confusion at 25 degree. 0 degree liquid changing into, start changing into solid, 100 degree liquid start changing into gaseous, that is vaporization. At 250 degree, very clear that it is very higher to the boiling point of water, so it will be in gaseous state. Then next problem of your study material, children. For any substance, why does the temperature remain constant during the change of state? Suppose I am heating water. I am heating it. What will happen? It will change. Here I have kept a thermometer also in this. This is thermometer, and I am heating water. Then what will happen? This water first it will get heated up, right? And when it will get heated up to a certain temperature, say the temperature will rise in the thermometer, right? and at 100 degree centigrade you will see that the water, it will start boiling, and after boiling you will see that the water, it changes into vapors. Liquid water changing into vapors, right? And here you will see that the temperature is constant, temperature does not changes. Why? You are heating, you are supplying heat. Water, liquid water, it is changing into vapors or gaseous state. There is no change in the temperature because all the heat which you are supplying here, it is being utilized, it is being used by this liquid water to change into gaseous or vapor state. The particles are, in case of liquid, the particles are closer to each other, and in case of gases the particles are far away. So, the energy which you are supplying in the form of heat, that is being utilized by this liquid water to change into gaseous state, and that is called as heat of vaporization, right. In the same way, if you take liquid water and you try to change it into solid, then what will happen? That liquid water, it will change into solid, but that temperature change will remain the same, the reading in the thermometer will remain the same, right. So, that is called as latent heat, clear. Then next problem of your study material, that is 11th problem. Suggest a method to liquefy atmospheric gases. Suggest a method to liquefy atmospheric gases. The gas which is present in the atmosphere, how you can liquefy, how you can change a gas into liquid, either by lowering the temperature, or by increasing the pressure. You can change a gas into liquid either by increasing the lowering the temperature, decreasing the temperature, or by increasing the pressure. That we have seen in case of carbon dioxide. Carbon dioxide gas, you can change it into, you can liquefy it, and you can change into solid carbon dioxide also, and that solid carbon dioxide is called as what? Dry ice. How you have done? By decreasing the temperature and increasing the pressure. So, you can liquefy the gas either by, or you can do together both the things, decrease the temperature also and increase the pressure also. Both the things can be simultaneously done. Then next problem in your study material is 12th one. Why does a desert cooler cool better on a hot dry day? A desert cooler we usually use when? During the summer season. During the summer season it is very hot and the atmosphere it is dry also. So, why does it works better or it gives a better cooling effect during a hot dry day. The reason being this, that during hot day, of course the temperature is higher. So what will happen? Humidity is less, temperature is higher. So of course naturally what will happen? More of the water will get evaporated. Evaporation, rate of evaporation increases with temperature. Evaporation increases with temperature. If temperature is higher, rate of evaporation is more. If evaporation is more, cooling effect will be more. And next, one more reason will be this. This is evaporation. One more reason, that if the day is dry, then what happens? Humidity is less. If humidity is less, what is humidity? Water vapor or moisture present in the air. There is no moisture, there is no water vapor in the air. So what will happen? The atmosphere is dry, humidity is less. So because of that, more of the water, this liquid water, it will get evaporated. It will this rate will increase, and therefore the cooling effect will be more during the hot, you can say, dry day. Then next problem, of your study material, that is thirteenth problem. How does the water kept in an earthen pot, that is matka, it becomes cool during summer? Here. This is the earthen pot and here is the water in it, right. Now, in this earthen pot, you can see that there are present small pores. There are present small pores in the earthen pots. Everywhere there are present small pores, and because of this small pores, the water, it goes here and it gets evaporated. Water goes out through the pores which are present in the wall of the earthen pot, and this water, as it goes out, it gets evaporated. And for this evaporation, the heat energy which is required, it takes from the water which is present inside the pot, and therefore this water, it becomes cool. It gets cool, right. So water present in the earthen pot, that is matka, there are present small holes or pores. The water which is present inside the matka, it goes out through the pores, it gets evaporated. Heat energy which is required for evaporation, it is taken from the water which is present inside the pot, and therefore that gives a cooler effect to the water, or water becomes cooled. Then next problem of your study material, that is the 14th problem. 14th problem of your study material, children. I am reading it out. Why does our palm feel cold when we put some acetone or petrol or perfume on it? Here this is the palm, and on this palm if I put some acetone, or if I put some petrol, or if I put some perfume all of you must be having at your home, you can just try, spray some perfume. What will happen? You will feel cool. Or you might be having at your home, your mummy must be having nail paint remover, that is also acetone. So put some drops of that on it. Spirit, doctors usually they put spirit on the body when they inject something, then they put spirit on the body. What happens? These things they get evaporated, their boiling point is very low. Acetone, petrol, and this the third thing which we are talking about, that is petrol, acetone, all these things and perfume also, they have their boiling point is lower. So what happens? As soon as you put it on the palm, they get evaporated, and when they get evaporated, the heat for evaporation it is taken from your palm, and therefore you get cooling effect. You feel like that it gives you cooling effect. The same thing with the doctor also. When he puts some spirit on your body, boiling point of that spirit is less. So heat from the body it is taken for evaporation of that spirit, and your body becomes cooler. This much part of your body it becomes little, you can say, numb, or you will have less sensation in that particular part. So when you get injected, you will have less of pain, or you can say your pain will be less. So this is about this thing. Then 15th question of your study material, that why are we able to sip hot tea or milk faster from a saucer than from a cup? If you have a cup and if you have a saucer, here also you have hot tea and here also you are having hot tea, but with the saucer I can sip very easily this hot tea, but if it is in cup, then I will find it difficult to sip. Reason being, just think of the factors affecting evaporation. More surface area, here surface area is less. Again I am telling you children, all the questions they are based on theoretical part. If theory is clear, then you can answer any question. Here it is based on what? The factors which are affecting evaporation. One of the factor is rate of evaporation depends upon the surface area. If surface area is more, evaporation is more. If evaporation will be more here, this hot tea will become cool, right? And this hot tea surface area is less, so this hot tea will not get cooled faster, so you will feel it hot and you will find it difficult to sip. But in case of saucer, you will find it that the tea gets cooler fast and you can easily sip, right? So that is about the 15th problem. Now come to the 16th problem of your study material, children. What type of clothes should you wear in summer? In summer, what happens? The temperature is higher. Again it is based on evaporation. The same reason that in summer temperature is higher, you feel hot, and cotton clothes, or you can say cotton, it has the tendency to absorb sweat. What is sweat? It is liquid, and you perspire more during hot season. If you will perspire more, then more sweat, you will sweat more, and that sweat will be absorbed by the cotton cloth. Synthetic cloth, they do not absorb sweat. So what happens? Here cotton clothes, they have the capacity to absorb sweat. sweat is liquid, it will get evaporated, and if it will get evaporated, then you will feel cooler, or you can say you will be more comfortable, right. And here if you wear a synthetic cloth, then synthetic cloth do not absorb sweat, and because of that, so there will be no evaporation and you will be uncomfortable, right. So during summer you must wear cotton clothes so that sweat gets absorbed by evaporation. You will feel cooler and you will be comfortable. Then next problem of your study material, that is 17th problem, children. Give reasons for the following observation. What is the observation? Naphthalene balls disappear with time without leaving any solid. You must have seen that naphthalene balls, they are kept in the woolen clothes. In woolen clothes we keep naphthalene balls. If these naphthalene balls, they are kept open, after some days they disappear. No solid, no liquid, nothing is left. After some days these naphthalene balls, they disappear. So where they have gone? Because sublimation, you have studied already. What is sublimation? Changing of solid directly into gaseous state without being changing into liquid state. Why a substance sublimes? Those substances which have their vapor pressure or boiling point lower, they only sublime. And when a substance starts boiling, when its vapor pressure becomes equal to the boiling point. So what happens here? This naphthalene ball, it directly changes into, from solid state, it directly changes it into gaseous state without changing into liquid state, and this process is called as sublimation. So it sublimes and it goes away into the atmosphere, and you see nothing is left. Then next problem of your study material, children, that is the 18th problem. Arrange the following substances in the increasing order of forces of attraction between the particles. And what are the substances given here? Water, sugar and oxygen. This is liquid, this is solid, and this is gas. You have to arrange them in the increasing order of forces of attraction. Increasing order. We know that forces of attraction is least in case of gas. So first will come oxygen, then next forces of attraction is higher in case of liquid. So next will come water, and highest will be in case of sugar because it is solid. So this is about the forces of attraction in case of solid. So see children, all the questions, they are based on the properties, characteristics, that is all. If those things are clear to you, those things are fixed in your mind, then you can solve any type of question. Then next problem of your study material, that is give reasons. Water at room temperature is liquid. Give any two reasons that is given. Water at room temperature is liquid. Why water at room temperature is liquid? If you increase the temperature, then what will happen? It will change into gases. If you decrease the temperature, it will change into ice, that is solid. At room temperature, water is liquid. Why it is liquid? Again see the structure of liquids, arrangement of particles in case of liquid. In case of this is water, water is liquid at room temperature. Arrangement of the particle is like this. Forces of attraction, force of attraction, it is less. The interparticle forces of attraction is less, and therefore it is liquid. It can flow, that is the reason it is liquid. All the properties which you know of liquid, write down, and that will give you, but main property is this, that the in between the particles, they are little far away, forces of attraction is less, and therefore it is liquid. The next is an iron B part. This is A part of 19th problem. B part, an iron almirah is solid at room temperature. The same we have discussed for that table, wooden table. Why do we call wooden table a solid? Because it has a defined shape. It is solid, particles are very close to each other, and it has a definite shape. Main thing is that it has a definite shape, and why it has definite shape? Because particles are close to each other, force of attraction is highest, and therefore it has a definite shape. Now next problem of your study material, that is problem number 20. Problem number 20. Why is ice at 273 Kelvin more effective in cooling than water at 273 Kelvin? Here, why is ice at 273 Kelvin more effective, it gives more cooling effect than water at 273 Kelvin. 273 Kelvin means, if you want to change it into centigrade, that will be 273 minus 273, that will be 0 degree Celsius. Here also water is at 0 degree Celsius, and this is ice at 0 degree and this is water at 0 degree. Now what happens here? This ice, it is giving more cooling effect. Why it is giving more cooling effect? This is what? Solid, and this is what? Liquid. How this ice has changed into this water has changed into liquid? By coming in liquid, the particles are far away, and in case of liquid, the particles are far away. In case of solid, that is ice, the particles, they come closer and it changes into solid. Now the energy which you are supplying, that heat energy which you are supplying to the water to change it into solid, that energy, it is being used up in what? In changing of the state. So what will happen? This will have less of heat, and that will have more of heat, and that is the reason it will give you more cooling effect, right? So here we means some of the problems we have discussed, children. Rest of the problems we will discuss in the next session.